Hi, welcome back. This is Mrs. Thompson again. Today we're going to continue with matrix operations, and in particular we're going to look at matrix multiplication. The requirement for matrix multiplication depends upon the sizes. So for instance, if the first matrix is n by m, the second matrix would have to be m by something else. So the requirement is that the columns of the first one has to equal the rows of the second one. And the end result then would end up being n by p. So whatever the rows are of the first one and the columns are of the second. So in this example, we have 2 by 3 and we have 3 by 2. So my end result is going to be a 2 by 2. Now, how does this work? Well, the first thing we're going to do is we're going to take row 1 and we're going to multiply it by column 1. Okay? And that will get me row 1, column 1 in my result matrix. So I'm going to multiply each of the corresponding parts. So I'm going to do 2 times negative 1. I'm going to do negative 1 times 2. And then 3 times 4, and then I add those together. Okay, then I go and I move to the next column. So I'm going to do row 1 by column 2. But we do the same thing. So I'm going to do 2 times 3. Then I'm going to do negative 1 here times negative 1. And then we'll do the 3 by the 5. And then we add those together. And now I've multiplied row 1 by both columns. If there were more columns, I would just keep going. Now we're going to take row 2 and multiply by each of these columns. So row 2, I'm going to do 3 times negative 1. I'm going to do negative 2 times 2 and 1 times 4 and add those together. And then I'll do it by column 2. And I'll do 3 times 3, negative 2 times negative 1, and 1 times 5. And now I do my addition to get my end result. So I have negative 2 plus negative 2 plus 12, so that gives me an 8. 6 plus 2 plus 15 gives me 20, excuse me, that's plus 1, isn't it? That gives me a 22. Okay, and then here I have negative 3 minus 4 plus 4. And then lastly, I have 9 plus 2 plus 5. So that's a 16. And there's my end result. Okay, so let's do one more. So this is 3 by 3. The second matrix is 3 by 2. So my end result is going to be a 3 by 2. So I start with row 1 by column 1. And I'll do negative 2 times 8, or plus 8, plus 5. Then I'll move to the second column, and I'll have 3 plus 20 plus 40. And then I move to row 2, and I do the same thing. So 3 times 2 is 6, 1 times 10, and 2 times 8. And then I do it to the second column, and I'll have 3 times negative 3, 1 times 10, and 2 times, oops, hold on. I messed up, didn't I? Let's check this again on the first column. 3 times 2, 1 times 4. I did. I skipped over into the second column. So let's try this again. So 3 times 2 is 6. 1 times 4 is 4. And 2 times 1 is 2. Then we do it by the second column, and I get 3 times negative 3. I get 1 times 10, and I get 2 times 8. And now we move to the third row, and I do 2 times 2, negative 2 times 4, and 4 times 1. And then I do it by the second column, and I'll do 2 times negative 3, negative 2 times 10, and 4 times 8. And then I add all these up. So negative 2 plus 8 is 6, plus 5 is 11. 3 plus 20 plus 40 is 63. 6 plus 4 plus 2 is 12. Negative 9 plus 10 plus 16 is 17. 4 minus 8 plus 4 is 0. And then in this last column, I get negative 26 plus 32, which is 6. And there's my end result. Okay? All right. Now, we could use this to solve matrix equations. So let's take a look at what this does. So we're going to solve matrix equations just the same way we would do any equation. So if I have an addition, I'm going to subtract that matrix. Whatever I do on the left side of the equation, I have to do on the right side of the equation. So this will go to 0 and leave me with 2x on the left. Then when I do this subtraction, I do 2 minus 3. I do 1 minus a negative 1. 4 minus 2, and negative 2 minus 5. Now I'm going to divide by 2, which means I'm going to divide this entire matrix by 2, and x will be negative 1/2. 2 divided by 2 is 1. 2 divided by 2 is 1, and then negative 7/2. And so I can find the missing piece. Because there are matrices in the equation, the answer will be a matrix. Okay. All right, so hopefully that gives you, between part 1 of this video and here, it gives you a good understanding of how to do all the various matrix multiplications, operations, including multiplication, addition, subtraction. We could solve equations with them, know when matrices are equal. Next time, we're going to use some of these operations to do transformations, kind of a geometry application of matrices, and then we'll expand on into various ways to use matrices to solve systems of equations. So hopefully you'll join me next time. And if you're in class with me, be sure to start working on your worksheet and get some practice to be ready to ask questions in class. Talk to you later.